Okay, so let's start the stream. Yeah. So think everything is okay. Let's see. Let's check. Yeah, I think my voice is little. Let's see. Okay, the gain is okay. Okay, so let's start. Okay, so let's start. Let's do some labs. I think I should do DevOps Docker. Right. So I need to complete this one, and then this 3, and then this 2, 3 to 5 and 6. So 6 lab total. Okay, I need to complete all of them. Okay, so let's go through some labs. Right. What should I do? Okay, so let's start. So this is introduction to Docker, and let's do a quick cloud, right? Okay, so let's start. Okay. So what I need to do is I need to complete this 2, this 3. Okay. Let's start. Okay. So okay, so let's see. Yeah, so this is a cheat sheet. Let's see, what should I do? I think yeah, so let's go to the why this one is connected and required. Yeah, so let's start. This part, let's do quick. Okay, let's see. Okay. Okay, so here it says okay, so lab name, introduction to Docker concepts, right? So objective, understand the key components of Docker, differentiate between Docker and traditional virtual machines, explore the role of containers in DevOps pipeline, prerequisites, basic knowledge of the command line interface, familiarity with Linux based operating systems, okay, a computer with Docker desktop installed. Okay, so let's try it on our VM. I have Ubuntu, so let's do it here. Let's see. I think I have Docker installed in this one. Let's see if I have Docker or not here. Let's see. Let's do a quick check. Yeah, so I have Docker installed here. Let's do. Okay, so eventually I'll do the labs inside like the containers of Nafi cloud. So this is for just a better understanding purpose. Let's do a quick check if I have Docker -v. Yeah, so I have Docker installed here also. So I'll do it. Yep. So let's do basic prerequisites, basic knowledge of the command line interface, familiarity with Linux based operating systems, computer with Docker desktop, install lab tasks. So task 1 is review Docker's key components. So subtask is understand the Docker engine. Okay, Docker engine is the core component of Docker responsible for creating and running containers. It consists of Docker daemon, manages the Docker objects, image, containers, networks, volume, etc. And there is Docker client, the command line interface CLI that users interact with. Okay, use the following command to verify your Docker engine installation. Okay, so let's do Docker dash version. Let's see. Sorry. Okay, so as you can see, I have already Docker installed. I can also do Docker -v, right? And the version will be shown here. So after that, explore Docker images. Docker images are read-only templates used to create Docker containers. They form the blueprint of your container. Okay, list available images with Docker images, right? So I can do Docker and images. Okay, so I need to do sudo Docker images. So sorry. Here sudo Docker images, right? So I have two images currently, hello world and my app in my like Docker images, right? So pull an image from Docker Hub using Docker pull and then hello world. So I can also pull like let's say this one I have pulled using this command Docker pull hello world. So understand Docker containers. Docker containers are lightweight and portable encapsulations of an environment in which application can run. Okay, run a hello world container with Docker run hello world. So I can do this one Docker run hello world. So I have already the image, so I need the permission, and then I can run hello world. So hello from Docker. This message shows that installation appear to be working correctly. Okay, so I have successfully run the hello world container, like right in the container, hello world image in the container. So learn about Docker registries. Docker registry is the storage and distribution system for Docker images, right? Docker Hub is a public registry, but private registrations can be set up for secure image hosting. Inspect Docker images on a registry using Docker search Ubuntu. So I can inspect Docker images on a registry using the search command Docker search, and then the I don't know why I need permission every time. Let's do this one here. Okay, so as you can see Ubuntu, there are multiple names of Ubuntu appears. So Ubuntu JRE, Ubuntu.NET, Ubuntu Redis, Python, and these are all from the Docker Hub, right? The Docker Hub registry has all these names of Ubuntu images here. So after that, task to discuss the difference between Docker and virtual machines. Docker versus virtual machine. So Docker containers are lightweight due to sharing the host OS kernel, leading to fastest performance and lower resource utilization compared to virtual machines. So the feature architecture: Docker containers share host OS kernel and virtual machine. Each VM include a full OS. Okay, performance higher due to shared resources, and virtual machines lower due to overhead of multiple OS instances. Portability across systems with Docker, less portable, tied to VM image. Okay, so task 3: how containers fit into a DevOps pipeline. Containerization in DevOps. Containers provide consistency across development, testing, and production environment, enhancing the software delivery process. Continuous integration (CI). So developers can quickly test and integrate code in standardized environments. Continuous development (CD). So deployments are more reliable as containers ensure the same environment across stages. Okay. So continuous integration, where developers can quickly test and integrate code in standardized environment. So whatever the phase will be, like the environment will be same, so that it can be tested and quickly tested and integrated, like right. And continuous development is deployments are more reliable as containers ensure the same environment across stages. So across stages the environment will be same for deployments, so that deployments are more reliable. Okay, so one is for test and integrate code, and another is for deployment. Example workflow: build, containerize the application, test, run tests with the container, deploy the container to the production. Okay. Conclusion: in this lab, you have explored the fundamental components of Docker, understood its distinction from virtual machines, and discovered how containers are integrated into a DevOps workflow to enhance software development and deployment process. By mastering these concepts, you will be well on your way to leveraging Docker in practical real-world scenario. Okay, so let's do a quick start the lab, and let's see here it will appear. Right, I'll not do the SSH here because there are only 1, 2, 3, 4, 5 and 5 commands, so I'll not do the SSH. So it will be wasted time. It will wasted my time. And we'll insert here and then move on. Okay, so it takes some time. So I have the last stream like 18th. So today is 18th. Correct. So when I have done the last stream, let's see. I have done it. Let's see. September 18th. So September 10th. Okay. So 8 days have passed. I haven't done a live stream. Okay, I need to be regular. A live stream, I think. Okay, so let's see everything. Okay, so I have done. Let's go inside the terminal. Let's open the. Okay, so what I need to do is docker delta version. Okay, so docker has installed, and then docker images. Okay, quickly docker images, and then there are one image hello world, and then I can use docker pull hello at the image name. So I have pulled the image. If it like it already have, so the pull command not okay, so I can run the hello world what I have pulled. Let's do a quick copy. See, and then docker run. Okay, so it will run a hello world image in the container, and I can also use docker search ubuntu. So let's right. Okay, so I can do a quick docker search. Docker search for an image. Okay, so yeah, so these are all the commands. To exit. Okay. So that's it. I need to delete the lab. Okay, and I need to move forward. Yeah, so I have completed this lab, so it has been deleted, and go to the next one. Now installing docker on your machine. So how to install docker? Lab 2, installing docker on your machine. Objective: understand the steps necessary to install docker on your operating system. Verify the successful installation of docker. Ensure that docker daemon is running properly. Okay, prerequisites: a computer with either Windows, Mac or Linux distribution, internet access for downloading docker, basic command line skills. Okay, task 1, installing docker. Step: install docker on Windows. Go to docker desktop for Windows download page. Key concept: Docker desktop for Windows contains Docker engine, Docker CLI, Docker Compose, Docker content, Trust, Kubernetes, Docker credential helper, and Docker Hub. Okay, so all of these are contained in one Windows like what is this called? Okay, so this is Docker desktop. Okay, let's save it. I have already Docker desktop here, so let's do quick. Yes, I wanna replace it. Let's do a quick download. Okay, so double click Docker desktop installer.exe to run the installer. Note you need to have Windows 10 Pro or Enterprise enabled. Hyper-V or Enterprise, Windows 10 Pro or Enterprise. Enable Hyper-V on your Windows if prompted. Okay, follow the install wizard to complete the installation. So let's do a quick installation. Install Docker on your Mac OS. Visit for Mac download page. Key concept: Docker desktop for Mac is the community version of Docker for Mac. Open the downloaded docker.dmg file and drag and okay, let's see, drag Docker to the application folder. Okay, so I don't need to do this. Install Docker on Linux, example Ubuntu. So update existing package list, sudo apt get update, and then install required packages. So I need to install these required packages, and then add Docker's official GPG key. I need to add the Docker's official GPG key, and set up the Docker repository. So I need to set up the Docker repository, and then install Docker engine. So I will install the Docker engine. After that, verify Docker installation by Docker RHEL version, and then Docker info, and then to confirm Docker daemon is running. So I need to systemctl status Docker, and key concepts command outputs the okay. So let's do this lab. Use WSL2 instead of Hyper-V recommended. Allow Windows containers to be used with this installation. Allow Windows containers. Okay. So let's see. Let's do a quick good morning. Okay, so I need to open this lab and quickly install Docker here. So I need to do a quick like SSH here because the commands are heavy. Let's do SSH here. I need to go to SSH, advanced SSH, use private key, and I will use the private key here. Right. Okay, it's taking some time. Your lab is ready. So library we can connect on a PEM file. So to view the YouTube. SSH. Okay, that's it. I have connected. Let's do a quick lab of this installation of the Docker in Ubuntu, right? So let's clear my screen, and I need to first of all update the repository, right? and I will do a quick shift right click, show the context menu. Okay, so let's do a quick update, and then I will do a required packages which are install apt transport https and then ca certificates and card and software properties common. Okay, so let's do a quick copy and let's do shift. So let's install all the dependencies, right? Okay, after that I need to do this one, add Docker's official GPG key. Okay, so I need to add the Docker's official GPG key, right? So enter. So I have added the Docker's official GPG key, and then I need to set up Docker's repository. So I need to set up the Docker's repository, and so that's it. Let's do set up the Docker repository, enter to continue, auto continue, and then I need to install Docker engine. So after that I need to, let's do this to enter to continue. Okay, so close and restart. No, I don't want to restart now, do it later. So why the okay, so that's it. Yes, and then I need to verify the Docker version. Okay, so I need to Docker dash version, right? Or Docker info. Okay, so Docker version says okay, so Docker version says Docker version 18.4.0 installed, and Docker info says version 18 and context default, debug mode false, and then all the plugins and path. Okay, so I have successfully installed Docker. Let's quickly use the daemon. Okay, systemctl status Docker to see the status of Docker, if it is running or not. So Docker service, Docker application container engine. So activate is failed since, okay, so loaded, service enabled, reset enabled, activate failed. Okay, logs exited, status 1 failure, right? I don't know. Let's do a quick systemctl restart Docker. So I need to give the password, which is this one, root underscore. Authentication failed, access denied. Let's do a quick sudo -su. Okay, let's do systemctl restart Docker. password is root. Authentication failure. Failed to restart Docker service access denied. Oh, so I don't know why this one is not working. Okay, so let's quickly go through. I have already done this one, and then I have already done this one, and let's see. Okay, so I have already done the lab. Let's do a quick. So how to delete? So yes. Okay, so we're done, and then connect now. Okay, so let's do delete everything. Let's delete it here. Let's delete it. Okay, so I have done this lab, and then next go to the next one. Okay, so that's it. Okay, so instances have been cleared. Let's go to this one, which is called file container hello world underscore lab. Okay, lab name is first container hello world. Okay, understand the basics of Docker containers, learn how to pull images from Docker Hub, execute and run containers, verify containers execution through output interpretation. Okay, prerequisites: familiarity with command line interfaces and Docker installed on your system. Refer to official Docker installation guide for assistance. Okay, verify your Docker installation to ensure Docker is installed currently on your system. Open your terminal, Linux, Mac, or command prompt, Windows, and run the following command, which is docker-version, and then output this display will show key include. Put the hello world image. Images are the blueprints for creating Docker containers. The hello world image is a simple Docker example. Okay, task: pull the image from Docker Hub. Okay, that is in Docker pull, and then run the hello world container. Running a container from a Docker image initiates the application. Okay, execute the container, which is Docker run, and then hello world. Expected output: a confirmation message demonstrating successful container execution. Typically includes instruction Docker followed and affirmation in communication with your Docker daemon. Key concepts: the Docker run command creates and runs a new container from the specified image. This command helps validate whether Docker is correctly configured and running on your machine. Step to analyze the output. The output from running the hello world containers provides critical insights. Key points: so Docker's greetings message confirm that containers are running well. If Docker is configured correctly, the output ends with a success message. Example: hello from Docker. Okay, case study: a successful message confirms correct installation, demonstrating the container's ability to echo messages back to the user. Technical insight helps in understanding the Docker client-server communication. Conclusion: in this lab, you have successfully created and started your first containers using Docker's hello world image. This step signifies a fundamental understanding of Docker's image and containers management, forming the basics for more complex Docker operations in the future. This simple execution is not only validates Docker installation but also illustrates basic Docker functionalities crucial for further learning in the containerization. Okay, first thing first, let's do in our container. Okay, let's check if I have already snapshot of this container or not. Snapshots. Oh, so I have snapshots of this container. Yes. Let's clear my screen, and then let's quickly jump through the commands, which is docker -v. Sorry. -v, and I have installed Docker this version, and let's do a quick docker pull hello -world. Okay, let us check. Okay, so permission denied because I need to give the sudo permission. Okay, so using default tag latest, so I need to like specify if I want to download the older version hello world, and then colon, and then the like version. Okay, so this has pulled an image. Let's do a quick run docker images. As you can see, and sudo docker images. As you can see, I have hello world, latest tag, and then this image id. So what I need to do to run this image, docker run, and then the image id or the image name. So I am copying the image name here, and permission denied because I need to sudo dash password is sorry. So let's clear, and I need to do docker images and then docker run and then the hello world, which is this one, and this will run a container. Okay, expected output. So I can do docker containers. Start. Let's see. Docker ps, I think. Yes. Okay, so no container is currently running. Let's do a quick clear. Okay, so I have already done this one. Let's start the lab and quickly do this 1, 2, 3 commands. Okay. Okay, so I have checked everything is running. Let's do a quick docker. How many labs are there? 30 labs. So I will complete 30 labs within like 1 hour. This is 8:50. I will have a breakfast and the target will be to complete 9:30. Okay, so lab is already connect now. So I need to do docker version pull and then run. Do a quick docker version, and then I need to do a docker run. Sorry, this thing was to pull. Okay, so that's it. Exit, and let's do a quick of the deletion of this lab. Let's delete this lab. So I have done this lab 6:56. Okay, so I think the lab is deleted. Let's do a quick check here. Yep, let's go to the next one. Okay, so this is listing managing containers lab. Okay, so So the lab name is listing and managing containers. Objective: understand how to start containers in background using Docker and learn how to list running containers and manage their life cycle. Okay. Gain hands-on experience with basic Docker commands like docker run, docker ps, docker stop, docker start, docker rm. Okay, so let's do basic knowledge of Docker. Docker installed on your system. Lab task: start a container in the background, list all running containers, stop a running container, restart stop containers, and remove a container to manage lifecycle. So first thing first, start a container in the background. Choose a Docker image. Note: we'll use Nginx image in this lab. Ensure you have it downloaded for faster deployment. So I need to do Docker pull and then Nginx, right? So I need to do a quick installation starting of the lab. So let's do it here for now. Sorry, Docker pull in Nginx, right? So this will, Docker pull in Nginx. So the default tag latest, and then I need to do docker run and then dash name and then my underscore nginx and then the nginx, right? And dash d means detached mode, to run in the background, right? Yeah, run in the background. Dash d, this flag enables detached mode background. Dash name to name my container, my nginx. Assign a name to your container for easy reference, and list all running containers using docker ps and container id using, okay, connect now. Unique identifier for each running container. Status: show how long the containers has been running. Stop a running container by using docker stop and then the container name, and restart a container by starting start. Restart a stop container by using start and then stop and then remove to remove the container. So let's do a quick. So first thing first, started. Okay, so I need to do docker pull nginx and then the tag name. So tag name is latest. Let's do the latest one. Okay, so it will download. Okay, so let's do a quick clear, and then I need to do docker run and then the container name. But before that I need to specify the detached mode, like this is option, and then the option name, to enter a name for my container which will be my nginx, and then the container name which is nginx, right? And then enter. So this is the container id, right? This is the container id. So if I do docker ps, I can see the container running. Sorry, docker ps, the container is running, and this is the id of the container, the name of the image, and the name we assigned to the container, my nginx. Okay, so after that let's do a quick docker stop of this one. Let's copy this one, docker stop, and then my container name, and it is stop the container. And to restart I can use docker start and then the container name, so it has start. And to remove I can use docker rm and this one. So cannot remove container is running, so I need to stop the container first, right? Docker stop my container, and then I can do docker rm. Okay, so I can do a clear and then docker ps. Okay, so no container running. So I can also verify using docker ps -a to list all. So as you can see, hello world and hello world, two containers remain. So I have removed the nginx container. Okay, so delete the lab. Okay, I have done this lab, and then go to the next one. Okay, so I've done this. Okay, so let's see. I need to do my breakfast. I'll take 5 minutes of rest. Okay, so let's do a quick I'll do a 5 minute of rest. Okay, so Okay, so let's start. Let's pause this. Okay, so let's start. Okay, so this is the which lab? This is fifth lab. So using Docker Hub and pulling images lab name using Docker Hub and pulling images, right? Objective: understand the purpose and functionality of Docker Hub, learn how to search for Docker images on Docker Hub, gain proficiency in pulling images using the Docker pull command. Okay, inspect downloaded images to understand images layer. I think I have done this one. No, I haven't done this one. Okay, basic understanding Docker dash version, and then understand the Docker Hub. Searching Docker Hub for an official image. Open your web browser and navigate to Docker Hub. So Docker Hub, this is Docker Hub official page, and I can explore the images. Okay, I need to explore, and then official beta. Can I find images? Let's see. Docker Hub is an official repository of containing container images. You can search for official images which are maintained by Docker, such as Nginx and MySQL. Step 2: use the search bar to find the official Nginx image. Let's see, where is the search bar? Okay, so I can search here, Nginx. As you can see, this is the Nginx official image. And MySQL, use the search bar to search and click on an official image is either created, maintained, and supported by Docker, or created by a company that owns the project associated with the image. Pulling an image using Docker pull. So open a terminal or command prompt, execute the following command to pull the Nginx image, and then this is the command, and then verify the image has been pulled by using Docker images, and then inspect the okay, so explanation: the Docker image command lists all images stored locally, showing important details such as repository, tag, image ID created, and size. Okay, inspect in image layer. Okay, use the following command to inspect the history and layers of Nginx image or Docker history, and then the image name. Images layer are stacked to create a single Docker image. Each layer represents a set of read-only files that form part of the images. Analyze the output to understand the composition of Nginx image. Explanation: the output reveals the size of each layer and the commands executed to create them. This helps understand the image's build process and can aid it in optimizing image size and layers. Conclusion: Docker Hub is a powerful resource for accessing and sharing containers images. By mastering the Docker pull command, you can efficiently deploy containers via popular images available on Docker Hub. Understanding image layers provides insights into how Docker images are constructed and optimized, essential for efficient image management and deployment. Throughout this lab, you enhance your Docker skills by interacting directly with Docker's Hub and managing images locally. With the fundamentals mastered, you can now explore more advanced Docker functionalities. Okay, so I have Docker installed on your machine. Ensure Docker is running currently by executing Docker dash version to verify your installation. Okay, so let's do it quickly. Dash version, and the Docker version will be shown here, and then Docker pull, and then the image name Docker pull Nginx. So the image will be pulled, and then I can use Docker images command to see the pulled images. Docker images, and then the images will be shown Nginx and hello world. So I can also use Docker history and then the image name to see the history of the image. Docker history, and then the image name, which is Nginx, right? Okay, so the history will be shown here, like when it was pulled and which version created by, and then commit, and then the image. Okay, so let's do a quick clear. And okay, so this was it. Docker history and then the reader flag. Okay, my screen is not recording. Oh no. Okay, let's do a quick. Okay, so let's do the next lab, which is using Docker Hub and pulling images lab. So I have done this one. Let's do a quick next. I don't know why the tick mark is not coming. I've already done this lab. Okay, so I have already done this lab. And then running interactive containers lab, right? So let's do this one, which is running interactive containers. Understand how to run an interactive Docker container, learn how to explore and interact with a Linux container environment, differentiate between interactive and detached container modes. Okay. Abstracts run an Ubuntu container interactively. Pull the Ubuntu image to ensure you have the latest Ubuntu image. Pull it from Docker Hub. So I can use Docker pull Ubuntu and then launch the container in interactive mode. Use the following command to start an Ubuntu container interactively. The -it flag enables an interactive terminal. So Docker run and then -it to interactively to turn on interactive mode, and then the image name, and then interactive, and T for sudo tty to allow interaction within the container, and then this is the location of bin bash. Okay, explore the container environment. Once inside the container, check available commands and the file structure to understand the isolated nature of the container environment. Check OS version inside the container. Okay, explore the container environment. Once inside the container, check available commands and the file structure to understand the isolated nature of the container environment. Okay, check OS version inside the container. Verify Ubuntu version. To verify the Ubuntu version, cast /etc/os-release. Explanation: this file contains the operating system identification. Okay, exit the container. To exit the container, type exit or press Ctrl+D to exit the container session. Compare interactive and detached modes. Interactive modes keep the terminal open, allowing real-time command execution. The container stops when you exit the session. Okay, detached mode run in the background -d flag with docker run and docker run -d and then Ubuntu and then sleep 100. So this will run in the background. This command run the container in detached mode executing sleep 100, keeping the container running for 100 seconds. Conclusion in this lab. Okay, now execute running the docker interactive mode, perform the basic operation. An environment checks inside a Docker, differentiate between running containers interactively and in detached mode. By understanding this fundamental concept, you are better equipped to use Docker for more complex tasks, automation, and infrastructure management. Okay. I don't know why this is taking so much time. But okay, so what I need to do is to pull the Ubuntu image, Docker pull Ubuntu, and then this will pull the Ubuntu image, and then I need to run it interactively. Docker run -it interactive mode and Ubuntu, and then the bash location, which is /bin/bash, right? So I am in the Ubuntu image, inside Ubuntu image, and then I can do the ls command. Okay, so Ubuntu image is running successfully. So I can also use to like the version of this Ubuntu image cat /etc/os-release release. Okay, Ubuntu, and then the version Debian. Okay, so everything, that's it. And then I can also use exit or Control D to exit, right? Control D. So let's do clear, and then I can also run Docker run in detached mode -d, and then the name of the image Ubuntu, and run it for 100 seconds in the background. So the image is running in the background, right? So I can do Docker ps. As you can see, sleep 100 is running in the background, which is 9 seconds ago. So this will do 100 seconds. You can do again. Yes, as you can see, 23 seconds ago and up to 21 seconds. Okay, so this will run till 100 seconds, and then this image will be running stop in the background. Okay, so this was the lab, and then I need to quickly exit. Okay, so delete the lab and then go to the next one. Delete it, to the next one. Okay, so this is Dockerfile Basics lab name Dockerfile Basics. Objective: understand the purpose and structure of Dockerfile, learn to create a simple Dockerfile using a base image, install necessary packages using Dockerfile instructions, build and run a custom Docker image. Prerequisite: basic understanding of Docker and how it works. Docker installed on your local machine. Installation structure can be found here. Okay, lab task: introduction to Dockerfile, brief overview of what Dockerfile is, explanation of how Dockerfile are utilized to automate the creation of Docker images, creating a simple Dockerfile. Begin with creating a Dockerfile that specifies a base image. base image. Okay, adding commands to install packages. Learn how to use run instruction to install software packages during image build. Learn how to use run instructions to install software packages during image build. Okay, how to use run instructions to install software packages. Okay, building the Docker image. Process of building a Docker image from the created Docker file. Running a Docker container. Executes the Docker container using the build image and verify the install packages. Okay, detailed steps. Introduction to Docker file. Docker file is a text document that contains all the commands to assemble an image. It allows setting up the environment, installing necessary software, and configuring system settings in a repeatable manner. Okay, creating a simple Docker file. Create a new directory for the lab, mkdir Docker file basics, and then the cd into that directory. Create a Docker file. Open a text editor and create a new file named Docker file, and then dot text editor. Include the following content. Use Ubuntu as the base image. From Ubuntu, and then the tag latest. Key concept: the from instruction sets the base image for subsequent instruction in the Docker file. Adding a command to install packages. Install the curl package. So add the following line to your Docker file. Update the package list and install curl. Run apt get update and apt get install -y curl. Explanation: run is a instruction used to execute command in the container during the build process. apt get update refreshes the package list, and then apt get install -y and then curl installs the curl package without interactive prompts. Okay, prompts: building the Docker image. Build the image from the Docker file. So Docker build and then -t and then the image name. Okay, Docker build is the command to build an image from a Docker file, and -t and then the image name tags the image with the name my event. Okay, so -t is for the tag of image name, to use the tag of the image name. Okay, and then the dot specifies the current directory which contains the Docker file as the build context. Running a Docker container. Run a container from the newly created image Docker run, and then the -it interactive mode, and then the image name, and then the bin bash. Okay, and then verify curl is installed, and then curl -- version. So that's it. In this slide we have learned to create a basic Docker file, install packages within a Docker image, and run a container from the build image. Docker file are powerful tools for building and deploying application in a consistent environment. Case study: many modern software development pipelines utilizes Docker file to ensure that application run the same way in every environment, enhancing both reliability and speed in deployments. Okay, this foundational knowledge serves as a starting point for more complex Docker compositions and container orchestration. So start this lab. Let's do the lab quickly. I need to create a directory, and then why this is taking so much time? I don't know. So much time. Come on. Okay, so let's do connect. Quickly jump to the terminal. Okay, so let's do quick mkdir docker file -basics. Okay, So cd and then docker file dash basics. Let's go to inside the directory, and then I need to include the following content. It's the page image. Okay, I think I done a mistake. Okay, let's do a quick let the lab. SSH once. So just set. Okay. Then what I need to do is here, and now I can copy paste everything. So I need to do a quick copy paste. File exists. So okay, I'm inside ls. Okay, so I need to create a docker file, copy, and then touch docker file ls. So I need to go to vi and then file. Let's go. Docker file. I need to use the Ubuntu as my base image, and then I need to install the card, update the package list, and install card. Okay, so this is the running command, and then I need to save by using Control Shift. I think Shift O. Yep, Shift O. Sorry, Control O, and then Control and then Enter, and then Control X. Yep. Control O, and then Enter. Control X. Yep. So I have successfully, let's see, get. Right. Okay, so I have done this, and then let's build by using docker build -t for tag, to use the tag name, which is my underscore Ubuntu, and then dot to specify that I have the docker file in current directory. So this will build the image, and after that I need to run it interactively by using docker run, right? Okay, so successfully build image and tagged. Okay, so I need to now run docker run -it to run it interactively, and then the tag name my ubuntu, and then /bin/bash. That's it. So I have successfully run it, and then let's do curl --version. So I have installed the curl version also. Okay, so this was the lab, and now I need to delete it from, close the session, and then I need to delete it from here. Okay, so I have deleted the lab, completed it successfully. Yep. So next, okay, understanding image layers and caching. Objective: understand the concept of Docker image layers and how caching works. Learn how to optimize Docker builds by manipulating image layers. Analyze the effect of command order in a Docker file on caching. Observe and interpret a build process output to identify cached layers. Okay, prerequisite: basic understanding of Docker and containerization. Docker install on your local machine. Familiarity with the command line interface. Setting up your environment, Docker version, confirm, create a basic Docker file, create a new directory for your Docker project. So Docker image layers, and then the cd into it, create a Docker file with the following basic instructions. Okay, use the official node.js image from node, and then the 14, create app directory mkdir or source/app, copy package.json and package log.json, copy package all.json to /install app dependencies, run npm install and bundle app source, copy expose app port, which is 8080, and start the app, cmd node, and then app.js. Build the Docker image by using this command, and use the official node.js image from node 14. Understand the impact of command ordering or caching. Analyze layer caching. Okay, summarize layer caching, not how unchanged commands in the Docker file result in cached state. Identify performance improvements during the build process. Evaluate. Reflect on how modifying the Docker file improves build efficiency, and explore strategies to optimize for frequent changes. Example, using multi-stage builds. Okay, in this slide we have learned how Docker uses layers and caching to build images efficiently. By strategically ordering commands in a Docker file, you can significantly optimize the build process, leading to faster deployment cycle. Understanding these concepts is crucial for efficient Docker image management, especially at scale. Further reading: explore more on Docker official documentation about layers and caching. Investigate strategies like multi-stage builds to minimize image size and enhance build speed further. Multi-stage builds. Okay. Building best practices. Okay, I got it.